Hi everyone, my name is James. Welcome to King's Fine Woodworking. Today we're going to build what amounts to a really simple table. These are actually going to be laboratory benches, like chemistry lab benches. I'm setting up a lab in my basement. I've actually started a second YouTube channel dedicated to science, and I need some lab benches in order to do some of the demonstrations that I have planned for that other video. So I thought this was a great opportunity to build the benches myself and to show you guys how I did this building procedure. If you're interested in checking out my other channel, it's called Always Learning, and I'll put a link to that in the description down below. For this table, I'm going to use 12-quarter oak for the legs. I really want 3-inch legs, or as close to 3 inches as I can get with this material. I bought it rough, and it's actually a pretty economical way to buy it. I just cross-cut it to the approximate length that I wanted, and then I'm going to go ahead and flatten one side of it on my jointer. Well, actually, my daughter Sai is doing that for me here. After we get one side flat with the jointer, we need to flatten the other side and bring it into parallel with the first side. So with that, we'll transition over to the planer. And I'll just keep the flat side down, the side that I already flattened, and that becomes the reference surface for the top to become planed nice and flat. And it takes a few passes to get everything down flat, and I'm just going to go until all the rough material is gone, and whatever thickness I have, I'm going to turn that into a square, and I'm going to make that the dimensions of the legs. I'm hoping it's close to 3 inches. It probably won't be exactly 3, because once you dress this wood down, it's a little thinner, you know, maybe 2 3/4, somewhere in that range. And then once I have those flattened on both sides, and the two sides are parallel with one another, I'll hold it up nicely against my jointer fence, and I'll go ahead and flatten one edge. This is going to bring this edge into perfect square with those two faces, and that's going to become a reference edge for me to take this piece of wood over to my table saw. And I've done one. My daughter Sai is going to finish up on the remainder of these for me. Looks like I'm going to be able to get 2 legs out of each one. And there we go. We have that nice, flat, perfectly square reference edge. Now we'll take that reference edge to the table saw and we'll put that against the fence. That's going to ensure that our board is now nice and square, and the blade itself is going to cut a piece off that's parallel to that reference edge. And I've measured it, so what I'm cutting off here are perfect squares, and those are going to be the legs. And luckily we were fortunate, we did get 2 legs exactly out of each one of those pieces, so our waste is actually pretty minimal. I actually chose red oak for this project for 2 reasons. One, it's fairly economical, especially when you're dealing with thicker wood like this, and also for nostalgia's sake. All through high school and college, all of our chemistry laboratory benches had frameworks that were made of oak, red oak specifically, and I just really like the look. It's what I grew accustomed to, and that's how I decided to build these. One of the cool things about this design is that it's extremely easy. This table basically would work for anything, a dining table or whatever, and it's something you could put together in just a weekend. And there's our 8 legs that have already been milled to size, and now I'm going to cut them all to length, make sure they're all the same length. Actually, we're going to do 4 at one length and 4 of them just a little bit shorter, because I need tables that have 2 different heights in them. You'll see why that is here in a little while. I'm just going to cut one edge square. I'll move it over to my stop, and I'll cut the other edge so that I'm touching my stop. And that's going to give me 4 legs that are all exactly the same length. Now, if you make this table, you probably don't want to order an epoxy chemistry lab top necessarily, but they make butcher block tops that would fit this. You could even use a sheet of plywood, or of course you could glue up some wood for the top. And just in case you're interested, I'm going to make a free set of plans for this, and there'll be a link down below in the description for you to get a free set of plans if you're interested. So now I decided I wanted to put a small roundover on all these sharp edges. It's oak and it's pretty sharp when they come to this razor sharp corner. And I'm also going to round off the bottom. I want the bottom of the legs to have a roundover, so if the table slid from side to side, it's less likely to chip or flake off an edge of that wood. The top I'll leave square, but the bottoms I'm going to round. This is just a 1/4 inch radius roundover bit, and it's in a little palm router, so it's real easy to put these on. Now, of course, typically you need to route from left to right, but this bit's so small and I'm cutting such a small amount, it's okay if we have to go the other way there briefly. And then Sai is sanding these as soon as I get done routing them, and so I'll be ready to start with the assembly phase right away. And that's the bottom, the end grain there. She's sanding that nice and smooth. If you don't sand the end grain real smooth and you put a stain on it, more will absorb in there and it'll get a little darker. Not that it matters. But here's the 8 legs all together, and this is the bottoms of the legs, you can see, because that's where the roundovers are. And so this is just about ready to go. I thought we'd go ahead and put some stain on it before we continue. Of course, the stain that was used on all those lab benches as I was growing up and going to college was this same golden oak stain. Somehow this seems to be ubiquitous in every chemistry lab in the country, so I wanted to use it. The nice thing about it is it's really, really easy. It's almost impossible to mess this stain up. You put it on thin, you put it on thick, whatever, it doesn't matter. You can wipe it off and you get a really uniform look no matter what. It's made by Minwax. This is golden oak, and in fact all the Minwax stains work really well. It does of course depend on the species that you're trying to stain. Oak just happens to be a species that is very, very easy to stain. You wouldn't be able to stain maple, for example, or cherry very well with a Minwax stain. You'd need to move to a gel stain or something like that. But if you're going to use oak, this is just a fantastic choice. So I know I'm going to end up dripping some glue on these when I go to glue together the rails and the table legs, and sometimes I just like to put a little bit of stain on first to get a little bit of pre-treatment going. It just makes it easier to sand off any, or wipe off or sand off any glue that I've got on there. And you'll kind of see that as we go forward too. And here's what they look like when everything is all complete and stained. And it looks really good. I kind of like this look. This is when I first started woodworking. This is the look I went for a lot of stuff. Back then in the 80s, everybody loved oak. Oak was like the /1 wood to use, and it seems like I don't use it much anymore these days. Okay, so now I'm going to move on to the rails here. For the rails, I'm using 5/4 oak. 5/4, of course, is 1.25 inches in the rough, but once it's been planed down, it is thinner. It's planed down to approximately 1 inch, maybe a tiny bit bigger. And what I'll do is basically the same thing I did with the legs. I'll cross-cut all of these pieces to be slightly longer than what I need, and then we're going to joint one edge straight. I don't have to do a face joint and then a plane because this wood is already surfaced from my dealer. The hardwood dealer provides a lot of wood surface. They just didn't provide the 12/4 stuff surfaced. So we just move right over to the jointer and joint one edge straight. They are supposed to be straight from the dealer, but sometimes they're not. So we'll joint one edge straight, and that's going to become my reference edge to use against the table saw. So you see I have the flat edge against the table saw fence, and then I'm ripping it on the right side to about 6 inches. So I'm using a pretty beefy rail, being 5/4 in thickness and being 6 inches, because the tabletop that we have going on here is really heavy. These epoxy tabletops weigh somewhere in the neighborhood of 200 pounds each. I think they're created with a ground rock, like a silica or a mica, mixed in with the epoxy. It just gives them a little bit of extra wear resistance and a little bit of high temperature protection. And so I want the whole structure to be beefy and able to hold a lot of weight. And so that's why we're kind of stepping up the thickness of some of the materials here. And when I'm done with the ripping everything down to the correct width, we'll go back to the chop saw, and now I'm going to cut everything to the exact length that we need. After squaring off the first edge, we'll move it against the stop on the left side there, and we'll cut it to the exact length that we need. Now that stop, if you'll see it here, I'll show it from the other side. It is a flip top stop, so it'll flip up a little bit, and so I can put a long board underneath it and do my cross cut. And then once I flip that board around to do my final cut to the exact width that I want, it'll drop back down in place and hold it there for me. So it's called a flip stop. And that board now is cut to the exact length that I need. Using a stop is important because that makes sure that all of the widths are exactly the same for all of the rails. We need 2 on the ends to be exactly the same and the 2 on the sides to be exactly the same. That'll ensure that we have a square table. So from here, I'm going to go ahead and move right into the assembly phase, and I'm going to show this whole thing in real time. It's only going to take about 4 minutes, and I'm going to show you how fast a domino jig will put this together. There are many ways to attach the rails to the legs. One is I could do a traditional mortise and tenon, where I would leave the legs a little bit longer. So I'm marking this for the inside of the table here, and I'm pointing an arrow to the inside. So I could do traditional mortise and tenon, like I was saying. I could also choose to use dowels. That would be an easy way to attach them. But I'm going to use the domino jig. And I'm going to show you how fast this domino jig is here. I'm basically identifying what parts are what so that I know how to put this back together after I've cut everything. And that arrow, once again, points to the inside of the table. So now I'm going to make marks where I want these dominoes to go. I'm going to put one about an inch down from the top. I'll put another one about 3 inches down from the top. And I'll put the third and final one about an inch up from the bottom of the rail. Now I want to make those lines a little bit longer so that I can see them clearly through the window on the jig to make sure that I put the holes in for the dominoes in just the right spot. So I'm going to use my square to do that. And if you could just bear with me, you'll see how fast this whole thing really goes together. So I'm going to take another square and just kind of hold the leg and the rail together. Make sure it's all touching everywhere so it remains nice and square. I'm going to use a real tiny square here to transfer that mark from the rail to the leg. And that way I'll know exactly where I need the dominoes to go in the leg. So everything lines up perfectly and we end up having the top of the rail flush with the top of the leg. So we've got the same situation here. We need to make those lines a little bit bigger. And we have to remember that these lines are actually the lines where the holes, where the domino holes are going to be cut. So I'm going to kind of give you an outline of that rail. The rail is going to kind of fit right there. And so you can see the holes will go at the cross sections of those lines, and the rail fits about right there. Now in order for the domino to read, I've got to transfer these lines up to the top because the part of the domino jig that we look at is the part on the top. It cuts the holes in the side, but you'll look at it on the top for alignment. So I'm transferring those lines around the corner to the top like this. So I guess this is a little bit of a domino tutorial. It's not really intended to be, but there, I'm looking through the top window of the domino to make sure I have that lined up. And we're simply putting the holes in the side. Pretty simple to do. We'll move over to the next one and do the exact same thing. And since I'm centered on that line up top and I know that line wraps right around to the bottom, then I know that's the center of my domino hole. And just like that, we have all 3 dominoes set there. So I was close about where I wanted those that rail to appear. Now I'm going to lower the fence a little bit to get to the center of the rail. I had it all the way up to get close to the center of the big leg. But now I've got this marked to go to the center of the rail, and we'll do the same exact thing. We're going to sight it on the gauge on top, make sure it's on that line, and it's going to put a hole right in the center of the rail. And we'll just move it over, get the middle one, then we'll move it over and get the end one. The exact same thing as we did on the table leg itself. And you can see there through the top how the gauge lines up. And there it is. Now those are in the center. Now the next thing and final thing to do is to do a test fit. So these are 10 by 50 millimeter dominoes, and I've got the right cutter and the domino for that, the domino jig for that. And we'll test these to make sure it all fits together and there's no problems, and if so, then we can move on. So these are called floating tenons. It's kind of like making a mortise and tenon, except there's a mortise on both sides and the tenon's kind of floating in the middle. And there you have it. It came out perfectly, and literally that took just barely 4 minutes to do. So we're going to go through and do that on all legs everywhere and all rails everywhere. Then I'm going to put a round over on the bottom of the rails. No need to put one on the top because the tabletop goes flush with the top, but you know, if we're picking up the table and we reach and grab the bottom of the rail, we don't want it to be sharp. So I'm just going to do the same thing, a real small 1/4 inch radius round over bit on the bottom, just for looks there. And of course we'll spend a few minutes sanding everything before we actually proceed to our assembly. And I'd like to give a shout out to everybody in the Kingsfine Woodworking community on Facebook. It's a Facebook group where woodworkers help other woodworkers. If you're interested, there's a link down below for that. From here, we're just going to move right into assembly. We'll put glue in all the domino holes and on the dominoes themselves. I like to get glue on both sides of every surface of all objects that will be glued together. That way we're never short on glue. There's no problem where we might have a glue-starved joint. Of course, you do want to make sure you don't have too much in the domino holes, because if your legs were a little bit thinner, you could conceivably split those legs. Same with the rail. If you have too much glue in the rail and you try to drive a domino in there, you get nearly an airtight fit and you could split the rail. So I am a big fan of gluing, probably over gluing, but that is one area you don't necessarily want to over glue because you might have problems damaging the wood. And we're just going to glue the second portion up here too. And we're going to put the short rails together first. All of them, we'll clamp them up, let them set for a little bit, and then we'll make the transition to the longer rails once those have cured. Kind of basically glue the table up into 2 stages. I'm using Titebond's quick set glue here, which is pretty fast. It actually cures in 15 minutes under clamp pressure. And so in a relatively short period of time, I can pull the clamps apart and then proceed to glue up the second set. So I definitely have more glue than I need there, which is fine. The extra glue that comes out, we'll go ahead and wipe that off. Yeah, just make sure I get it good and wiped off, and then we'll also sand that area lightly before we go to put a stain on the rail. It'll be very obvious if you start to put a stain on the rail and there's a white spot or a clear spot where the stain didn't absorb, then you know you have glue there still and you need to sand that off. But if you get a wet rag and you tackle that right away, that's really not a problem. So we've got the second side glued up here, and we'll put that together. I get it pretty close there. It didn't quite touch, but that's not really a big deal. We'll let the clamps come together, and the clamps will pull it nice and tight. This parallel clamp grabs pretty deep, but I do have a long rail. The rail extends past the parallel clamp just a little bit. And so what I think we will do is we'll put a clamp on the feet end as well to kind of pull it together real tight, just in case the joints don't quite seem to be pulling together tight at the top section there. But this right here will cure that. And we don't need to put too much pressure here, since this ends up putting a whole lot of torque, just enough to bring those rails down to tight with the legs. All right, so we waited a couple hours, and then we till it dried a little bit, and then size pulling it apart here. And we're going to go ahead and glue up the long rails at this point. That's one of the nice things about Titebond's new quick set glue, is that you just don't have to wait very long to put everything together. I'm going to put a link to that in the description, just in case there's anything that you might like to use from this build, and especially if you get the plans. Like I said, free plans are in a link down below, but I'll have a materials list as well, so that you can go online and get these things also. And you know, you don't have to have dominoes. I did mention that. A doweling jig would work just fine. You could put 3 or 4 dowels in here, and that would be plenty strong for a tabletop like this. Dominoes are just real fast, real easy, and probably one of the strongest joints that you can make. It's on par with a real traditional mortise and tenon joint. So Sai's got that glued up nicely. She's getting glue on all of the dominoes as well. And then we'll just begin putting the long rails onto here. If you do end up doing a project like this and you use Titebond's quickset glue, you have to be careful, because the quickset glue is a very fast setting glue. You only have about 5 minutes worth of open time, so you have to move very quickly through gluing everything up. And you can see on that one there, that is just exactly the right amount of glue. So it helps if you have a couple of people to do a glue up like this, so that you can proceed through it quick. Otherwise you'll need to use something that sets a little bit slower, like Titebond 3 for example. And then we'll just proceed to putting this together. And sometimes with the glue it's a little hard to bang the joints all the way home, so you don't necessarily have to. As long as your clamps are ready, you can put clamps on it within a few seconds. It's no problem. The clamps will pull it together tight for you. Now this is a long joint here, and so I've got to use a pipe clamp. Pipe clamps are nice. You could buy the pipes any length you want and put your own clamps onto it, and they work fantastic. Good. So we're going to clamp that top and bottom just like we did the other one, and set that aside to dry. While we do that, we're going to cut some cleats. So this is basically 1 inch thick material here. So I've set my table saw fence also at 1 inch away from the blade, and I'm just going to cut a bunch of strips out of scrap wood that I have left over from the rails, and these cleats I'm going to screw to the inside of the rails all around the tabletop, and I'm going to screw from those into my tabletop. If you happen to like our builds and our projects, maybe you could leave a thumbs up, and even better yet, maybe you could subscribe to our channel if you haven't already. That's the one thing that helps our channel grow, and we'd really appreciate it. So I think we're going to go ahead and round off one corner on these, the corner that's exposed down below. And normally you do move the router from left to right, but I can move it from right to left for short distances like this to make it easier for me, so I don't have to start right at the corner, and that's really okay because it's a very small radius roundover. Anything bigger and you might have some tear out or difficulty moving the router in that direction. And I'm also going to round off the ends. That's going to kind of give us a nice finished look all the way around underneath there, and it's going to eliminate any sharp edges that anybody might accidentally touch should they be reaching underneath the table. And since they don't have to be exact, because I'm going to take the time to sand them as well, I can just kind of bunch them up and router the ends all together at once also. And that's pretty good. And now Sai is doing a little drilling for us. She's going to put a pre-drill hole into this. Maybe it's not called a pre-drill, huh? Maybe it's just a drill hole, or a hole that was previously drilled by the time we get to it with our screws, with a little bit of countersink. She's going to put them on this side and then rotate 90 degrees and put them on the other side too. That's going to allow us to screw this into the table, and you see she's doing the other side now. It's going to screw into the rails on the table and also screw up into the tabletop. Now these holes would have to be slotted, the ones going into the tabletop, as opposed to a straight hole if you're going to use a wooden top that might expand and contract. I'm using a solid top that's not going to expand and contract, so I didn't bother making them slotted. But if you make this and you want to use real wood, something other than plywood, then you're going to want to make those slotted. And those are the ones that are going to go into the table. And now we're just going to go ahead and put these directly into the rails. And I do have quite a few here. I want this to be really secure so that we can move this thing easily just by grabbing the tabletop. So I do have quite a few screws to go in this all the way around. And we're just going to line this up flush with the top of the rail and load it up with screws. And we're going to do this all around the whole perimeter. I don't have full-length long pieces to go for the two sides because my scrap didn't really account for that, but I pieced it together in pieces, which is really just fine. And that's what it looks like when that's complete and they're installed all the way around. Next step is to put a stain on it, of course. This is one of the things that's great about this stain. I can actually go over the legs again if I want to, if I just keep it quick and wipe it off right away. It's not really going to get any darker. This stuff is just fantastic for that reason. And we're just going to coat everything thoroughly. And when that's all done, here's a quick look at what that looks like. Reminds me of the chemistry benches back in school, so I love it. It's all ready to have the top installed, but we might as well take the time and put a lacquer finish on it first. And I'm just going to spray on a lacquer finish. We'll spray on probably 3 or 4 coats. I'm using an HVLP sprayer. And this is the first coat here. I'm using a satin polyurethane, I'm sorry, not polyurethane, but a satin lacquer. It's made by Deft, D-E-F-T. So I'll get one coat on everything, and then I'll get a second coat, and then I'll do a very light sanding with 600 grit to kind of get it smoothed out. And I'm using the Apollo Eco 4 sprayer. Works really good. It's just like the Fuji's. I think it's a little bit better. And Sai is actually putting the final coat here. And of course it's very important to go nice and smooth and keep uniform distance away from your surface, especially for your final coat, because that's the coat that matters. And it's finally time to install the tabletop. So I've turned the legs upside down on the top of this epoxy tabletop. Remember, this is for a chemistry lab bench, and so my tabletop is solid epoxy. It's a very heavy tabletop. In fact, it's rock hard. We had a really hard time putting these holes in. I think traditionally these tops are epoxied into place, but I wanted to be able to remove the legs if I needed to. So I had to actually drill all of these holes twice. I had to put a little pilot hole in first, And I did that with a little 5/32 bit, and we did that all the way around, and then we followed it up with our countersink bit, which enlarged the hole just a little bit more. And even that burned quite a bit, so we had 2 drills going with 2 countersink bits, and I kept them lubricated with oil, and we just alternated bits for every other drill time so that we didn't burn out the bits. We did manage to break 1 screw when we were putting them in. The epoxy is pretty unforgiving. Once the screws go in, they hold on rock solid, and they don't penetrate the epoxy very deep, just about maybe 1/2 or 5/8 of an inch. So I wanted to get a number of screws around the perimeter, and you see about every 4 or 5 inches I have them. She's taken a moment to vacuum the dust out of the way, so it allows so there's no dust in the way when the screws go in, to make the screws even tighter. I wouldn't even bother with that if this were wood going into wood, but going into that rock hard epoxy, this is important. And that's it, just setting the screws down in there. And that's really all there is to this project. This concludes it. The bottom of the epoxy is pretty ugly. I guess I didn't really notice that until I got here on video. It's just a cast product, but there they are, all finished, and that's the top. Now the reason my table on the left is shorter is that is the one for my stereo microscope and related instrumentation that goes mounted onto that, and then the other table is for more experiments and things like that. So that's what it looks like. I hope you enjoyed watching the video. Thank you very much.